How are you? I hope you are fine. Today I am going to discuss about the graphical representation of motion. Okay, in this video I will discuss about some displacement time graphs, velocity time graphs. So I have drawn some sample graphs to understand this concept. Okay, so it is very important and easy concept, and without knowing these concepts you cannot proceed in this chapter motion. Okay, so firstly I will tell about the displacement time graphs. So I take the graph number 1. Here we take displacement along the y-axis and we take time along x-axis. Every graph represents some information about the slope, velocity, acceleration and motion of the object. The particular curve, particular line represents some information, gives some information, and we extract these information by studying this graph. So how can we get this information? I will teach you about this. Okay, firstly I have to explain you that in displacement time graph there is a slope. Every graph must have some slope, and this slope represents velocity, means nature of velocity, I would say. So in this graph, displacement time graph, there is a straight line in xy plane. It means at a particular time displacement constantly changing. Okay, it means the slope here is constant. The slope here is constant. If slope is constant, then definitely in this graph velocity is constant. So velocity will be constant. The nature of velocity is constant. And if we talk about acceleration, so velocity is constant means there is no change in velocity. It means there is no acceleration at all. So there will be no acceleration. If there is no acceleration, velocity is constant, then definitely motion will be uniform. Okay, the nature of the motion will be uniform. So by this graph we have studied these concepts about the slope, velocity, acceleration and motion. Okay, I hope it is clear to you. It is very easy. Sometimes the graph will be taken as like sometimes the graph taken as from a particular point. For example, it means there is a particular displacement at this position, and graph is increasing in this way constantly. No problem with that. The slope is constant here, velocity is constant, but initially there is a displacement, and in before that case the displacement will be 0, but at this case the displacement will not be 0. Okay, so remember this point. Now we take graph number 2. In graph number 2 we again use these information about the slope, velocity, acceleration and motion. In this graph, if we take the slope from the horizontal axis, from the time axis, so there is no slope because the particular line is parallel to the time axis. Is parallel to the time axis means there is no slope, angle is 0. So it means the slope will be considered as 0. If slope is 0, so velocity will be 0 here. If there is no velocity, so we don't need to calculate acceleration here. There is no velocity at all. So definitely it is not in motion. Particle is not in motion. In this graph, particle is at rest. It means only time is increasing. Displacement is not changing. Displacement at a particular point is fixed. So that's why motion is not there. Particle will be at rest. Now we take graph number 3. In graph number 3, we directly observe that the particular line is parallel to the displacement axis. It means displacement is changing constantly, but time is not changing. Is this possible? I think it is not possible. This graph practically not possible. Without taking time, displacement cannot change. If displacement is changing, that's why some time needs to be taken. Now we move to the equation graph number 4. In graph number 4, if we take the slope is increasing. Slope is increasing. If slope is increasing, So what about the velocity? So velocity is also increasing. If velocity is increasing, so definitely there is an acceleration in it. Particle is accelerating and there is a change in velocity in upward direction. It means there is a positive acceleration here. There will be a positive acceleration. And what about the motion here? Okay, the motion will be non-uniform. The motion will be non-uniform here. When we move to the fifth graph, in fifth graph slope is decreasing here. Okay, slope is going to downward. It means slope is decreasing. If slope is decreasing, what about the velocity? Velocity is also decreasing. If velocity is decreasing, it means there is a retardation, means negative acceleration. And negative acceleration, there is acceleration, means motion will be non-uniform. Definitely. Okay, I hope it is visible to you. Now, if we take this sixth graph, in this graph, the slope is constant. No doubt. Slope is constant. But in this condition, you observe that there is a particle at origin at a maximum displacement. When time is increasing constantly, so particle is going towards its initial position. It means at this point the displacement is its displacement becomes 0. So in this condition we theoretically explain that particle is going towards initial point. Going towards initial point. Means displacement is going to be 0 at this point. Okay. So these are the some graphs, displacement time graphs. Now we study about the velocity time graph. So now we take velocity on y-axis instead of displacement. So now we take velocity, okay, along the y-axis. In all graphs. Okay, now if the graph is changed, so definitely information will be changed. Okay, we cannot extract same information as we written in the displacement time graph. So in this velocity time graph, if there is a graph like this, okay, so definitely there is a slope constant. But in velocity time graph, slope gives the information of acceleration, not of velocity. Okay, slope gives the information of acceleration. Slope gives the information of acceleration, not of velocity. Okay, now here is slope is constant in first graph. So according to this nature of the slope, we can decide the nature of acceleration. So here acceleration not in 0, acceleration will be constant here according to the nature of slope, because in velocity time graph slope gives the nature of acceleration. So acceleration is constant, means acceleration is present there, particle is accelerating, so definitely there will be a velocity but not in constant. Velocity is increasing here according to time, constantly increasing. Velocity is constantly increasing, so motion is no more uniform. Motion will be non-uniform here. Motion will be non-uniform. Okay. Now similarly, we take the graph 2. In graph 2, again your slope is 0. Slope is 0, so definitely your acceleration is 0. Acceleration is 0 means there is no acceleration but particle moving with some constant velocity. So velocity is constant here. If there is no acceleration, it means velocity is constant. So particle now is in motion now. In uniform motion. Particle will be in uniform motion. Now you can observe that in the displacement time graph, the informations are different, but in velocity time graph, informations are different from the graph of the displacement time graph. In graph 3, we can again observe there is a line parallel to the velocity axis, means velocity is changing, okay, but time is not changing. There is no change in time according to this graph. So without changing time, velocity is changing. It is not practically possible. Again, this graph is not possible. I am talking about this graph just because of this your awareness. That's not more than that. Graph number 4. In graph number 4, the slope is increasing. That's true. Slope is increasing. So what about the acceleration here? Acceleration is also increasing. According to that, so what about the velocity? Okay. So velocity is changing now. So velocity is also changing here, but not at constant rate. Velocity is non-uniform here. Non-uniform change is increasing. Velocity we can also write increasing condition. Motion will be non-uniform here, definitely. In fifth graph, again slope is decreasing. So slope is decreasing. So acceleration is also decreasing here. Okay, acceleration decreasing is non-uniform acceleration will be there. And what about the velocity here? So velocity is also decreasing but non-uniform here. Velocity is decreasing but non-uniform velocity. In this graph, again we take about the slope. Slope is constant. Slope is constant. So particle is accelerating but negatively, because at the origin point there is a velocity, maximum velocity. Okay, but when time goes, so velocity is changing and going towards the value 0. It means the particle again going towards its initial point. Okay, it is going towards its initial point. It means velocity is going to be 0 after time t. Okay, now we can justify this result from this graph. Okay, so these are some velocity time graphs, and these are very important to understand the graphical representation of motion. There is one more thing I will tell you about that. For example, if we take in this graph, in graph number 1, if there is a line from a particular point like this, okay, so at this point it is being observed that there is a particular value of velocity. Particle is moving with initial velocity here, and velocity changes by a certain value after time t. This graph represents. But in this graph, in this line, velocity is 0 initially, but in this graph, velocity has some finite value initially. Okay, so this is all about the graphical representation of motion. I hope it is clear to you. Thank you very much.